All right, so we're gonna listen. We're gonna talk about the sum of angles identities again. So today we're gonna have this alpha and beta where we actually don't know the angles, but we know some information about the angles. So anyway, we're gonna find the exact value of its trigonometric expression given that sine of alpha is 4/5, and alpha is between 0 and pi over 2. So what does that tell you about alpha?
It's in between 0 and 9 degrees.
I said that. What quadrant is that? Quadrant 1.
That's what 0 through 9 degrees means.
So let's draw a quadrant 1. And let's go ahead and just draw alpha and make a triangle out of it. So if we know the sine of alpha is 4/5, what do we know?
The hypotenuse is 5, and then the opposite side is 4.
Very good. What about the adjacent?
It's the square root of 5 minus the square root of 3. It's 5 squared minus 4 squared.
But don't we already know that?
3, 4, 5.
Okay. All right. And so looking at all the things we have to find on 1 through 4, I would go ahead and just write down the sine, cosine, and tangent of alpha. Now, they already told us what the sine of alpha is, so you don't have to rewrite it if you don't want to, but I'm going to just so it's all in the same place. Okay. That's what we know about alpha. And there is another angle called beta. But the cosine is negative 4/5. Oh, no, it's not. Just kidding. I'm looking at the wrong side. The cosine is negative 12/13. And beta is between pi over 2 and pi. So what quadrant is that? Second. All right, so I'm going to go ahead up here and draw quadrant 2. And draw beta. Okay. And so if the cosine is 12/13, the adjacent is 12, the hypotenuse is 13. Does anybody know the opposite just off the top of their head?
15.
It is not 15. It has to be less than 13 because 13 is the hypotenuse. It's a Pythagorean triple.
11.
It's way smaller than both of those numbers.
6. 7.
All right, so obviously you guys don't know that Pythagorean triple. 5, 12, 13. So if you were doing this one on your own, you would just do Pythagorean theorem like what Ashton was saying earlier. We're going to do 13 squared minus 12 squared, which would give you 25, and then take the square root, which would be 5. I would like for you guys to know that Pythagorean triple, but if you don't, I know you know the Pythagorean theorem. All right, so you guys take that triangle, write down the sine, cosine, and tangent. They told us the cosine, but you could redo it if you wanted to. Okay, so be careful that your tangent and your cosine are both negative in quadrant 2. So what we're going to do on example 1a is find the sine of alpha plus beta. So the first thing I'm going to do is look at my identity sheet, and in the place of S, I'm going to put in alpha, and in the place of T, I'm going to put in beta. You may have these memorized. I don't know if you've used them quite a bit. If not, it's okay. You don't have to memorize them. All right, and then I'm going to go back at the top of my page and just fill in what all these things are. We already found the sign of alpha. They also gave us the sign of alpha. So everywhere I have sign of alpha, I can put in 4/5. Cosine of beta is negative 12/13. Cosine of alpha is 3/5. And then sine of beta is 5/13. So that's all the trigonometry for this problem. But we're not done. We have to just do some simplifying. So just remember, you're just using those calculators that aren't very smart, but you could do this in your head without a calculator, probably better than if you were typing in one of those, but that's okay. We're going to multiply across the top and across the bottom. And we're not going to reduce as we do this multiplication. So you might notice that these fives, if we were only doing this multiplication, those fives would cancel out and you get 3/13. The problem with that is if we got 3/13 here, we'd have to find a common denominator, and that would just not be fun. So just multiply the numerators, multiply the denominators. Don't reduce until the very, very end. All right. So we have a common denominator. So to add these, we're just going to add the numerators, and we're going to get negative 33/65, which will not reduce. And that's it. It's a little bit of a different way to use the same identities. Now, some people in my other classes were a little confused about the ones that were subtraction. And this is the first year I've had to teach it this way because all the previous years, the subtraction formulas were on the reference sheet. So we didn't really have to worry about finding another way to do it. But on B, where we have subtraction, what you would need to do is rewrite that as addition and have it be alpha plus negative beta. Okay, and then we go to our identity sheets. And in the place of S, we're going to put in alpha. And in the place of T, we're going to put in negative beta. And so make sure you're looking at the cosine one for sum of angles. All right, so what you're going to need to know is if cosine and sine are even or odd. So what about cosine? Is it even or odd? The even. And on an even function, what happens to the negative? It goes away. So that's going to be the same as cosine of alpha, cosine of beta. All right, sine is an odd function. And what happens on the negatives for odd functions? It comes out in the front. So that negative would change that minus to a plus. Now that is actually the formula we used to use for cosine of alpha minus beta. We just had to find it.
You still work it out without having that sign change to the subtraction symbol?
You would have to be really careful that when you did the sine of beta that you had it be negative 5/13. Yep.
Yeah, but like in the end, it would be minus a negative.
Yep. And you changed to a plus.
So I don't have to worry about swapping that as long as I keep track of it.
Nope, you don't. Okay, so I want you guys to go up at the top of your page and fill in all those fractions for cosine and sine of alpha and beta, please. And then we are just multiplying our numerators and our denominators together. We're not going to reduce because we just multiplying it this way will have us automatically have a common denominator. And then when we add, we should get negative 16/65. All right. Any question? All right, let's look at the tangent one. The tangent sum of angles is always going to be the most difficult one because you end up putting fractions inside of a fraction. So I'm going to go ahead and just write down the formula. And at the beginning of the problem, we figured out what all these things were. So for tangent of alpha, I'm going to put it in 4/3. So that's two different places. I have to put that 4/3. And then tangent of beta is negative 5/12. Two places to fit that. Right. And this could be a very tedious problem. If you were like trying to actually add these together, you'd have to find a common denominator. Now, I'm going to tell you what I would do. I wouldn't do that. What I would do is I would leave this alone for a second. I would change it a little bit because I don't like having plus and negative, so I would change it to 4/3 minus 5/12. But I wouldn't find a common denominator. I would just leave it for now. All right, and then go ahead and multiply this, but don't reduce. All right, so multiply negative times a negative is a positive, and then 4 times 5 is 20. 3 times 12 is 36. All right, so if you do these things like what we wrote, this number right here will be the number that you're going to multiply by to get rid of all the little fractions. So multiply by this to remove little fractions. Now, this is up to you, whether you want to do it in your head or use a little calculator to do it. Let me show you both ways. So if you're going to do this in your head, what I would do is reduce 36 over 3. What would that reduce to? 12. And then multiply 12 times 4. That's just going to be regular 48. Okay. And then you can do this here. Reduce. Reduce 36 over 12, which is going to be 3. 5 times 3 is negative 15. That's up to you. If you want to just do it in your head. If you would rather just type it in the calculator to do 4/3 times 36, I would probably do 4 times 36 divided by 3. That way, for sure, you're not going to get any kind of weird decimal. Like sometimes if you do 4 divided by 3 times 36, you'll get like 48.00001 or something weird like that, or 47.9999. So anyway, if you do it that order, it will definitely work. All right, so in the denominator, you definitely don't need a calculator. So we would multiply 36 times 1, multiply 36 times 20 over 36. That's just going to be 20. All right, and then it's just subtracting on the numerator, adding on the denominator, and that's it. All right, Any questions? All right, so what is going to be kind of weird about D?
Secant.
Yeah, we don't have a formula for secant. So what do you guys think we should do?
Change it to cosine.
You're going to use the cosine rule. And then once we get down to the end where our answer is just something like this, then we'll just do the reciprocal. All right, so I'm going to write down the cosine rule. And I've already found all these things. I did this at the very beginning, so I can just write down or just fill in what these cosines and sines are.
So we're gonna get the same answer as B.
No, B was minus. This one's addition. All right, so it looks like the cosine of alpha plus beta is going to be negative 56 over 65. So the secant of alpha plus beta is negative 65 over 56. Any questions? Okay, so the one we're doing, the very last one is like what we did yesterday, except it's in degrees. And when our angles were in radians, I told you like what you needed to add or subtract to get that angle in radians. If it's in degrees, I'm not going to do that. So what we're going to do is find two special angles that add or subtract to give you 75 degrees. And then with radians, we were talking about the special angles had a denominator of 6, 4, or 3. In degrees, the special angles are multiples of 30, 45, and 60 degrees. So what do you guys think? Right, 30 degrees and 45 add to give you 75. So we would rewrite this as the sine of 30 degrees plus 45 degrees. And I showed you this yesterday on this exact problem that we couldn't just distribute the sine. That does not make sense for trig ratios. But what we can do is use that identity for the sum of two angles with the sine. So I'm going to put it 30 degrees in for S and 45 degrees in for T. All right, I'm going to draw a hand over here. I have it on the board, but for people watching the video, I think everybody's really good with the hand in radians. But the hand also can work for degrees. So 0 degrees and 0 radians are the exact same angle. What do you guys, if we're doing special angles, what do you guys think the pi over 6 is? Yeah. So they go in numerical order from least to greatest, from pinky to thumb. So that's going to be 30 degrees. This one's going to be 45. It kind of looks like a 45-degree angle when you hold out your hand. And then 60 and then 90. So you can still use the hand trick for degrees. I do when I'm just trying to hurry up and figure something out. So if we want to do the sine of 30 degrees, you use the 30-degree finger, which is the ring finger, and it's the square root of the bottom over 2. 45 degrees, middle finger, square root of the top over 2. 30 degrees, cosine is going to be the square root of the top over 2. And sine, square root of the bottom over 2. So this is going to look just like our answers did yesterday. So when we multiply our fractions together, we should get some combination of square root of 2 and 6 in the numerator, and then 4 in the denominator. All right. Do you guys have questions over this today? All right. Hopefully today made it make a little bit more sense, or you got a little more comfortable with the formulas. So someone in my third period thought that these were the same alpha and beta as the front. They're not. So we have a brand new triangle for alpha, a brand new triangle for beta. So make sure you redo that or you'll be doing the wrong problem. So your assignment is on the back of that worksheet.